Okay, so we have 4 rules for drawing rays for spherical mirrors, and we'll go through each of these rules, and they're all basically the same for mirrors, and then we'll also see the same for lenses, or very similar rules for lenses, and then I'll show you all the various rays. So the first rule is pretty easy. We just draw a ray that's parallel to the axis. And then once you draw that ray, it reflects back through the focal point. Remember, this was our definition actually for focal point. So parallel to the axis and then through the focal point. The next one is you draw a ray through the focal point, sort of like the reverse of number 2, or number 1 rather, and then it reflects back parallel to the axis. Next, you draw a ray through the center of curvature. And it reflects back on itself. And then finally, you draw a ray to the center of the mirror. And the reflected ray just follows the law of reflection. And that is that theta I equals theta R. All right. All the rays follow the law of reflection because they're reflecting rays, and so the incident angle is always equal to the reflected angle, but it's a little easier if you just draw it to the center of the mirror to see that, that those two angles are the same. I'll show you that in just a moment. Now, these both apply to convex, remember that's like the security mirror, and concave, that's like the shaving mirror, although just in slightly different ways. We'll always position the object on the optical axis. So if I have a mirror like this, this is what we call the optical axis, this line. And so we'll always put the object on the optical axis. We'll always put it like right here. And the rays that come off of this object are always going to come from the top of that object. Say this is our focal point. This, for example, would be rule number 1, parallel to the axis and through the focal point. And then the image is located where the reflected rays cross. So I'll draw rule number 2 here as well, through the focal point and parallel to the axis. And now our image of this object is going to be right here. So the image, the bottom of the image is always going to be off the optical axis, and then the top of the image will be wherever the 2 rays cross. Right? So this is my object, and this is my image. And notice that we see in this case the image is inverted, and it's a real image. It's inverted just because of the way that I've drawn it, because the rays cross below the optical axis. Remember, this is what we call the optical axis. Optical axis. And since the rays cross below the optical axis, this image is inverted. Since the image is on the same side as the object, then it's a real image. Because the object is in the real space and the image is in the real space, it's a real image. All right? For concave mirrors, you can have 3 different scenarios. You can have the concave mirror outside the focal point, as the object can be outside the focal point. It can be inside the focal point, or excuse me, at the focal point. Or it can be inside the focal point. And in these, you'll get different images for each. If it's outside, it will be a real inverted image. That was like the previous one I drew. We'll see these in the ray diagrams. If it's at the focal point, there will be no image at all. We can see this from the mirror equation, by the way. 1 over F equals 1 over P plus 1 over Q. If P equals F, Q goes to infinity. I'll leave you to work that out on your own. And if it's inside the focal point, it will be a virtual image. It will be upright in single lens or single mirror systems. Virtual images are always upright, which we'll see why that is in a bit. It's the way the signs work, because Q is negative, so N is positive. Virtual, upright, and also a larger image. All right. This is like the shaving mirror or the makeup mirror. Right. Your face is upright and it's bigger because you're inside the focal point of that mirror. All right, so we're going to have these three scenarios, and I'll draw the rays for each of them for our mirrors. We'll pause there, and I'll pick up next with the ray diagrams for each of these.